Okay. Welcome, everybody. Tonight's speaker is Marion Clement. Marion has been working on raptor conservation and owl research since 2015. She began her work under the mentorship of David Brinker, who was one of Project Owlnet's creators. After helping Brinker with a barn owl nest monitoring study, Marion discovered her passion for wildlife. She worked as a wildlife biologist for 5 years in Maryland, where coincidentally she met my brother, and then pursued a master's degree at Clemson University to study habitat selection of barred owls along an urban gradient. Marion first moved to Colorado in 2020 to work for the U.S. Fish and Wildlife Service on threatened and endangered species. Then she joined Bird Conservancy of the Rockies in 2022 as the Mexican spotted owl coordinator. On her own time, Marion started a Northern Saw-Whet Owl banding station near her home in Fort Collins, Colorado. So without further ado, the main attraction, Marion Clement.
I'm not the main attraction. The Saw-Whet Owl is. You got that wrong. Am I good audio-wise? Yeah. Awesome, thank you. Thank you all for coming today. I have to admit, I was a little nervous for this talk. I haven't given a public talk in about 5 years, pre-COVID and then some. But seeing all of your friendly faces today have calmed my nerves. So thank you for that. Very excited to be speaking tonight about one of my favorite owls that I've ever worked on. We'll see what other owl I work on in the future, but so far it's my favorite. Very thankful for Fort Collins Audubon, as well as Fort Collins Natural Areas program for hosting this talk. AJ, where are you? Let's see, there she is. Yeah, you came to me with this idea of presenting on this work, so I'm really grateful for that. It's very exciting for me to get to share my research on this owl species. So before I jump in, I just want to explain the title of my talk, A Tiny Menace in the Forest. Obviously, saw-whet owls are predators. They hunt a lot of small rodents in the forest, but that's not why I titled my talk this. I titled my talk A Tiny Menace in the Forest because saw-whet owls are very expressive and they will let you know when they're pissed, which is exactly what this one is doing. I've disrupted its night because of our banding activities, and it's not afraid to give me a piece of his mind. So you will see some very cute pictures tonight. Saw-whet owls are very charismatic, and watch out for these expressions that they have, because they have many of them. And not all of these photos, these great photos that you'll see tonight are mine. I tried to include as many of mine as possible, but there's also some really great one that I pulled from some pretty amazing photographers from the Macaulay Library. So you'll see the credit under the photographs when that's the case. So many of you are going to be familiar with this owl, although I sincerely doubt that most of you have seen this owl in the wild. It is a pretty elusive owl. It tends to spend a lot of the daytime hiding in thick, brushy stuff. And that's because it's chicken nugget size. So a lot of things want to eat it, and it knows that. It camouflages and hides during the daytime. And so it eludes and escapes even the most avid birders. So if you have seen one, raise your hand if you have seen one in the wild. Nice, actually that's a decent amount. So consider yourselves lucky. But anyway, this owl has made the news recently and is getting more attention. Namely, 2 years ago, there was an article about one being found in the Rockefeller Center Christmas tree. This 75-foot Norway spruce was cut down from upstate New York, traveled 170 miles before being erected in New York City. And lo and behold, this little forest gnome came along with it, hadn't eaten or drank in a few days, and so it needed some help, some fluids, some food. But a rehab center took care of it, and it was released, and it was nicknamed Rocky after Rockies Air Force. In addition to that, if you are subscribed to the Cornell Lab's newsletter, you will know that this owl recently won the very prestigious award of cutest owl. And that's really no surprise to any of us, right? It's a heartthrob, really. I wasn't going to tell you about me and my story and how I got here, but John pretty much covered it all because I completely forgot what biography I gave you ahead of this talk. So we don't really need to talk about that. But I did want to point out that Dave Brinker, which is featured here, as John mentioned, was one of the creators of Project Owlnet, which is involved in my work on Northern Saw-Whet Owls. He's really a mentor to me, and nowadays I just call him my science dad. He's taught me everything I know as a raptor biologist and then some. And so we still talk and still collaborate today. But essentially, I wasn't always a wildlife biologist. I actually majored in something else as an undergrad, but kind of stumbled into it. And after Dave put a barn owl in my hand, that was pretty much that. I just wanted to do that for the rest of my life. Worked very hard to get experience working on birds of prey specifically. That's what really jives with me, I guess. But a lot of different other bird species. And then, as John mentioned, did my master's on barred owls and urbanization study to see how they adapted to urban landscapes. And then eventually ended up as the Mexican spotted owl coordinator for Bird Conservancy of the Rockies. Pretty much my dream job, right? Never thought I would get an owl biologist job, and here I am. But Northern Saw-Whet Owls are still my favorite. Owls in general are my favorite. And one of the things that's very exciting about owls to me is that they are still very much understudied. So there's still a lot that we have to learn about owls in general, and Northern Saw-Whet Owls are no exception. We know almost nothing about this bird. So I'm going to do my very best to pretend that I know some things about it, but I'll be clear about what's still uncertain and what we still need to learn about it. Despite being widely distributed, incredibly charming, we have virtually no information about its baseline population data, right? How is it doing? Is it declining? Is it increasing? Is it stable? What habitats does it prefer? There's still a lot of questions that we need to explore. So part of this banding work that I do in Fort Collins, as John mentioned, is trying to elucidate some of those knowledge gaps. And it's not just me, it's a wide network of other banding stations trying to answer some of those questions. So we'll learn more about that as we go through this talk. But first, let's talk about identification, right? How do you know that you are seeing a Northern Saw-Whet Owl if you come across it? It is one of our smallest owls, not far behind flammulated owls, elf owls, and pygmy owls, about the size of a robin. It's mottled brown with white speckling, especially on the back. I said rufous streaking here. It's not really rufous. It's more of a lighter brown, chocolatey brown streaking on the chest. It has a pretty distinctive facial disc, as you can see in this picture, but no ear tufts like a screech owl. And it has bright yellow eyes, and the Y marking above the eyes that you see here is pretty distinctive about this species, right? So if you see the Y marking, odds are you're looking at Northern Saw-Whet Owl. You should consider yourself lucky. There is a subspecies that looks very, very different from the rest of the species that occurs across North America. This subspecies is called the Brooksea subspecies. It only occurs on Haida Gwaii. Hopefully I pronounced that right, but it's a large island off the coast of Canada, the Pacific coast. And as you can see, it looks very different, right? No white marking on the forehead, very rufous, and very different behavioral patterns as well. So around here, the owl that you are most likely to confuse the Northern Saw-Whet Owl for is our boreal owls. Boreal owls, however, have a much paler facial disc. They've got some black framing around the facial disc too. And they are larger, but as you know, size can be really tricky to tell, especially from a distance. So one thing to note is just like many other raptors and owls, one cannot distinguish male and female owls. They have the same plumage. However, the juveniles look pretty different, right? Yeah, it kind of look like bobbleheads to me, pretty adorable. I hope the people on Zoom heard the awe and oohing. Is this better? I'm told that. Okay, is this good? John, I did need an X on the floor. All right, I'll try to stay right here. Okay, but the sound is okay, right? Is that right?
Because this happened.
Being right. Okay, thank you. Okay, so much darker head, kind of that deep, dark chocolate brown, and a rufous, uniformly reddish chest on the young one. So if you see one of those birds, you are seeing a brand new hatched bird, so one that is still maybe less than 2 months old. So that means you've got a nest somewhere close. Some other interesting physiological features to discuss are that they have thick feathers running down the legs all the way down to the toes, as you can see in this photo. They are a cold hardy species, right? So that helps keep them warm. Some jet black talons, that's what we call claws in avian ecology, and some bright yellow foot paddings that, as you can see, has some texture to them, right? All the better to grab and hold on to slippery, furry prey. They've got some specialized feathers on their facial disc. They're pretty rigid if you ever get to touch them. That's because they carry the sound, carry vibrations of their prey, right? Rustling the leaves, for example, to their ears, which are highly sensitive and asymmetrical. So one ear is going to be very high up on the head compared to the other that's going to be low. That's all the better to triangulate their prey and then to pounce on it. And that's actually been tested in the lab. Northern Saw-whet owls have just 1 degree of error in terms of their aim, right? So you do not want to be prey to one of these vicious little predators. And if you've never seen an owl ear before, well, here it is. Not many people get to get that close to a saw-whet owl, and they look pretty strange. We were actually taking an owl out of a mist net with my friend Sarah the other day, and we got to the ears, and the ear kind of opened up as we took the net off of the bird, and she was like, ah! She just yelled like, something's wrong. I'm like, no, that's just his ear. As you can see, there's some specialized bristles there too that are capturing the vibrations from the facial disc and then amplifying those sounds. So very, very good hearing on this owl. All right, let's talk about vocalizations and get familiar with them, because that's really your best chance of ever seeing a Northern Saw-whet owl in the wild. Northern Saw-whet owls have a lot of different vocalizations, 11 that have been documented. Although I'm sure there's more that they only say behind closed doors. Their vocalizations does change in pitch based on temperature. Think of cold, shivering, higher pitched, faster, but also with individuals as well. It's very similar to a northern pygmy owl, right? So they're easily confused. But northern pygmy owl are more active in the daytime, whereas northern saw-whet owls are only going to be calling after dark. So just think about what time of day it is when you're not sure. So the first call we'll listen to is the advertising call. Hopefully this will come through on Zoom. We'll see. But if you're not hearing it on Zoom, it's a higher pitch. This is technically what northern saw-whet owls are named after, the wet sawing. I'm not really hearing it, but I've never heard a saw make that sound before. Maybe they do. To me, it sounds more like a bus backing up. So anyway, it's an interesting call. It's mostly done by males. Females do it, but very rarely, very consistently. They'll do it during the courtship period, so the early spring. That's going to peak in April in Colorado. They do emit these other calls, and this is most of the calls that we hear when we're banding them. So during migration is going to be those calls, because they're not going to be doing their territorial breeding song when we're trapping them. These calls are more of contact calls. They can be agitated calls, like to warn others of a predator, etc. So let's take a listen to those. Yeah, so sometimes it kind of sounds like a meow almost to me. I thought that it was mountain lions sometimes when I'm out there in the blind, but it's just the owls coming in. All right, next, let's talk about diet. This bird obviously does need to go on a diet. They primarily eat small rodents, like you heard me say before, mostly mice, deer mice, white-footed mice are the ones we have that are native to here. As well as some shrews, some voles, some house mice, right? So a really good predator for household pests. Infrequently, if they can catch them, they'll get some bats, some young squirrels. Birds make up a pretty small percentage of their diet, but they have been known to predate on robins and cardinals, which are about their size. So that's pretty interesting. Northern pygmy owls as well. And those larger invertebrates as well. So beetles, cicadas, grasshoppers, the Brooksy subspecies, that was that really reddish subspecies off the coast of Canada, does focus on intertidal invertebrates, so things like copepods you would find on the beach, which is pretty cool. It's just an island bird, so it has a different diet. But yeah, all of that foraging shows how wide the breadth of their diet can be. They're basically just opportunistic predator. You're small enough and you're close, I'm gonna get you. They hunt at night, nocturnal hunters, and they hunt low to the ground, so about 3 feet off the ground. And they're called perch and drop predators. So they're gonna find a nice branch and they're just gonna sit there and wait until something walks by underneath them and then pounce on it. When they do get something, they'll eat the head first, as you see this little guy doing right there. If it's too big and it can't swallow it, it's gonna stash it and then come back for it later. And just to give you a sense of how much they need to eat, an average female needs to eat about 17 grams per day, which is about the size of a mouse. So just one mouse a night is all it takes. All right, let's talk about romance. I know you guys are dying to hear about that. Northern Saw-Whet Owls are monogamous, but only for one breeding season. After that, they say sayonara, and they never breed with the same bird ever again. So they keep it exciting that way, I guess. Their courtship is from January to May, so early spring. During this time, the male will do that advertisement call that we heard earlier. Sometimes it will sing near a cavity, a suitable cavity, although in the end, the female is always the one to pick the cavity, right? So sometimes the male makes the wrong decision and she's gonna correct that. Glad to get a couple chuckles out of that one. So the male, if it spots a female that's interested, is going to circle her in flight. It's going to hunt for her, feed her, show her that he's a good hunter and is going to be able to provide, preen her, and then they'll go into a cavity, copulate, and she will lay some eggs. Before we go on, I do want to talk about the nest site. They are cavity nesting obligates, right? So they're not ever going to make their own nest. This is true to most owls. Most owls do not build nests. So they don't add any feather lining, any branches. They just use what's there for them. And so those tree cavities are typically going to be excavated by some larger woodpeckers. So here out west, it's largely going to be northern flickers. But out east, pileated woodpeckers also excavate cavities that are big enough for them. And they do readily adopt nest boxes as well. Some other smaller owls tend to prefer natural cavities, but this one is pretty adaptable to nest boxes. The clutches, so the number of eggs is 4 to 7, on average 5. They're laid at 2-day intervals, and the female starts incubating as soon as she lays her first egg. So what that means is that the siblings are going to have an age difference, right? Because they're going to hatch at different times. She's going to be incubating those eggs, the female, for 27 to 29 days, about a month, and then brooding them until they can thermoregulate. until they have enough feathers to keep warm for another month. So think about that next time you're on a Frontier Airlines, which like sardines. She is just stuck in this little tree hole for 2 months, and she's really not stepping out of that cavity much, other than just take a quick poo, maybe stretch the wings, take a drink, but other than that, she's going to be sitting on those eggs. The male doesn't share that duty with her. And then there has been some findings that sometimes there's clutches or eggs laid in July, perhaps just replacing the clutch that failed early on, maybe even second clutches, but there's just so much unknown about that. Just there hasn't been that many reproduction studies for Northern Saw-whets. Yeah, pretty cute, huh? So the male is going to be providing the food for the chicks and the females the whole time. He's going to use different roost sites. So during the day, he's going to sleep in different places to make sure he's not bringing attention to the nest site. He's going to stash prey around the nest, sometimes up to 24 items. The cool fact is if those items, if it's early in the spring and those items freeze, the female will actually incubate that prey item to bring it back to warmth so she can feed it to her chicks. Yeah, pretty cool. So the chicks weigh 7 grams at hatching. So that's just the size of a pencil or 2 pennies, pretty light. Just 8 days later, they open their eyes. They're fully sized at 28 days, but they still have a lot of growing to do in terms of their flight feathers, etc. They are well capable of flight after leaving the nest, just 4 to 5 weeks after hatching. And they're going to be fed by the male for another 2 months after leaving the nest. So that's pretty long parental care when you think about it, especially for such a small bird. Pretty impressive. They are believed to be able to breed at just 1 year old, so just 1 year later, but that's just a big unknown. We have no records from the wild. And most importantly, they are rarely ever re-encountered in their natal area. So as soon as they leave that nest site, they peace out, never come back. As I said before, Northern Saw-whet owls are chicken nugget size, so they do have to worry about all kinds of predators. Pretty much anything that can get a hold on them will eat them. That includes a variety of different owls, including eastern screech owls, great horned owls that we have here. Broadwing, Cooper's hawk, peregrines, if they can find them during the day, they'll munch on them, and then squirrels will definitely take the young Northern Saw-whet owls. But that's if they can catch them, right? So before they can fly. I want to briefly mention the fright position because this is a pretty interesting thing about this. This species of owl will always prioritize camouflage over escape when faced with a threat. And so when frightened by something, the Northern Saw-whet owl is going to erect its forehead feathers, giving us that mean look, as you can see in that photo. It's going to compress its body, raise a wing to the beak, and essentially just have a stare down at the predator, and then fly away, but at the last minute. Sometimes I've heard of people even hand grabbing them because they just stay still until the very last minute. So if you see a bird doing this in the wild, you are harassing it. So take a couple steps back. That is the fright position demonstrated for you by this picture. We have a pretty good idea about how long these little owls live because we have a lot of banding data, and you'll see some numbers on that a little later on. But Northern Saw-whet owls live about 9 years in the wild. That's pretty comparable to other similarly sized owls. There is a record of one living in captivity for 16 years, but when you're getting takeout every day, life isn't super hard. So they do tend to live longer in captivity. All right, I know I haven't talked about where this owl occurs yet, and you've been dying to find out. So here it is. But the main answer is we don't know. There's still a lot that we don't know about this owl's distribution. It is widely distributed, as you can see, but there's still so much we don't know about its breeding and wintering extents. There's a lot of uncertainty of its northern range limits as well. The breeding here is going to be shown in darker blue on this map. You can see circled the Haida Gwaii, the Brooksy subspecies where it occurs. But typically you can see that its breeding range closely aligns with western forests, with boreal forests, and then with northern forests out east. So tends to like those colder, higher elevation forests, right? Especially for its breeding range. But when it's wintering, it kind of gets pushed around by the snow, and it can go down as far as some of our southern states, like South Carolina, where I've banded them before. But it is breeding in the front range around here, and it does stay here year round. There's quite a bit of variance in its distribution that has to do with prey density, right? Where rodents are doing well that year. Its habitat preference has been described in a number of ways. Some studies have said old growths, some studies have said early successional forests, conifer only, deciduous only, mixed forests. They've been found in tree plantations, in swamps, in scrublands, in beachy dune habitat. So either this owl is highly adaptable or we just don't really know. And I think it's a little bit of both. There's still a lot to learn about what the habitats this species prefers. So I think a better way to think about habitat is what are its needs. So we already know, that it needs cavities, right? Most of those cavities are going to be in deciduous trees. It needs hiding spots in the winter to roost in. Those are mostly going to be conifers. And it needs branches that are low to the ground. So it needs an understory, right? If the habitat, the forest structure is very open, it's not going to have a good place to perch and wait for prey. And lastly, it's very driven by small mammal abundance. So here in Colorado, that's going to be mostly ponderosa, pine forest, and spruce fir mixed with some understory as well. And I've added this picture here, just a screenshot from Nextdoor. I'm sure you guys are familiar with Nextdoor. Someone posted that they had one near their mailbox. So we don't typically think of this owl as a backyard bird, and I don't think they are, but they do occur in urban environments actually pretty often. So it could be an owl in your backyard right now. All right, let's talk about migration because this is a pretty important part of our banding activities for this bird. So migration, most of you will know, is a predictable twice-a-year movement between two very different geographic areas. To really call a species a migratory species, most of the population needs to move. And it's a high risk, right? It requires a lot of physiological expenditure on behalf of individuals. And so it's mostly taken when the situation is dire, when you need to move around to find food. And up on the right, you'll see two images of some great migration tools that I invite you to check out on your own time. The Audubon Bird Migration Explorer just came out. It gives you the migration patterns of many, many different species. And Birdcast is hosted by Cornell, but came out of CSU. So that's pretty cool. And uses radar to give you live updates about where the birds are migrating. Northern Saw-Whet Owls, up until the 1990s, were believed to be non-migratory, and that's because nobody really knew what they were doing. Nobody was trapping them. We just had no idea that they were migratory. But netting revealed huge movements of birds. We're talking about catching 200 birds a night during the peak migration activity. And so that's when people started paying attention, saying, oh, maybe this bird is migratory. In general, fall migration has a lot more individuals that we catch in spring migration. So we see a lot of fall banding stations, not too many spring banding stations. And Northern Saw-Whet Owls also do this interesting thing, which is called an eruption. And that happens every 4 years. Basically, what that means is that individuals are always migrating every fall, but every couple of years we get this huge influx of birds that's way beyond what we expect. For example, 5 stations in the Northeast banded 2,596 birds in one season, when typically their average is about 200 birds a year. So do you see that? That's a huge, huge change. We think that these eruptions are driven by rodents, and in fact, there's a lot of other raptors and mammalian predators that also show this kind of cycle, this boom and bust that reflects their rodent prey, right? So rodents, we know, just breed, and then they eat everything around them and they crash. And so a lot of the predators that are heavily relying on rodents as a food source are also going to have the same thing, where when their prey is really good, they're going to have lots of kids. And then all of a sudden, these kids are not going to be able to feed themselves because there's not enough mice around. So then they push south, and that's when we get to see these big eruptions. But because rodents aren't always doing the same thing everywhere across the species range, those eruptions are not going to be the same across the Northern Saw-Whet Owls range. And so this is a figure that I pulled from a blog post from Nancy Drilling. She used to work for Bird Conservancy. She used to, well, she's still banding Northern Saw-Whet Owls, but at the time she made this figure showing that the eruptions do not occur on the same year at the same stations, right? So we see an eruption in 2012 that peaks in North Dakota, but the eruption happened in 2011 for Slim Buttes. So pretty interesting distinction across the species range. Migration for the Northern Saw-Whet Owl is much more documented out east. That's because we have a lot more banding stations trapping these guys. But we know that migration is for Northern Saw-Whets are going to be concentrated along mountains and water edges, although they have been documented to migrate over water. And there's this pretty amazing example of a group of Saw-Whets that came down on a fishing boat that was 70 miles away from shore. All of a sudden, all these little owls were on deck, probably exhausted from a storm that pushed them offshore. Yeah, I wish I was there for that one. A really interesting thing about Northern Saw-Whets is that they do seem to skip avian flyways. And so an example of that is that a bird was banded in Wisconsin and then 9 days later in North Carolina. So it crossed the Appalachians. And then the speed of migration, Saw-Whet Owls are not these long distance migrants that just change their whole physiology and put on a ton of fat and then travel for 10 consecutive days to their final destinations. They're going to make these short stopovers. So it's not terribly fast, but if they have a good tailwind, they can travel pretty quick. And an example of that is that an owl was trapped at 5 in the morning, caught 16 hours later, 55 miles away. That's got to be the record. But otherwise, it averages around 18 to 34 miles a night. In terms of how this applies out west, we really don't have a lot of information on this. And that's because the Western states in general have only contributed to 6% of the banding data that we have since 1960. Colorado itself has only contributed to 0.3% of the banding data. And so it's really tricky to talk about patterns and such when we have such limited data. But as you can see, I did pull some banding recoveries from the Denver region, which is that star you see here in the center. And we had 4 recoveries that I pulled from the Bird Migration Explorer. One in Grand Junction. Who was here from Grand Junction? There they are. And then one in New York City. Could that be Rocky? I don't know. And then 2 in Canada. So in general, there's just a lot of information gaps migration out west that we need to work on answering. So you've heard me talk about a lot of different life history traits on this bird, and over I have said, we're not sure, I don't know, not enough data. So why in the world are these owls so understudied? Well, there's a couple of reasons. First of all, they are nocturnal, so nobody likes to stay up past midnight. They're very secretive, as we mentioned, difficult to spot during the day. Because they're nocturnal, they're rarely going to be observed by surveys like breeding bird surveys, Christmas bird counts, etc. They're also very small, which means that if we want to put transmitters on them, which is a great way to get some concrete owl relocations, like where does the bird go on the landscape, those transmitters have to weigh less than 3 grams, which is the weight of a penny. And typically when we try to cut weight on transmitters that we put on birds, we try to use solar power because the battery is the heaviest component of the transmitter. But we can't use solar power, right? Because they are nocturnal and they spend all day hiding in thick brush. So that solar panel is not going to recharge the battery. And there's one more thing that makes it perhaps above all very, very difficult to study them, is that saw-whet owls are completely nomadic. So they have no natal site fidelity, no breeding fidelity. They're not going to come back to the same nesting area year to year. No wintering fidelity. They just kind of seem to like amble around, follow the wind. I don't know. They never do the same thing year after year, which means that we can't use a type of transmitter called a logger. A logger can be really small. It can be all the way down to 1 gram. But it collects data on the hardboard, and then you have to catch the bird again to get the data. But on these birds, if you want to put, a $500 transmitter on its back, the odds are you're never going to see that transmitter again. So it's a huge hindrance to research. And there's technology is always advancing, so we're working on pushing through some of these obstacles, but it explains a lot of the unknowns that we still have about this species. So now I want to change gears a little bit and talk about banding Northern Saw-whet owls. Back in the day, in the 1960s, Northern Saw-whet owls were thought to be very rare and mostly occurring just in Canada. But then one day, the story says that some raptor biologists that were trapping daytime migratory hawks left their nets open on accident and then came back to them in the early morning and they had all these owls waiting for them. And so they thought, that's really cool. We've never banded saw-whet owls before. We didn't even know they were here. And so they tried a couple additional things and found out that during the fall, it was really easy to catch these guys. And then a little later in the 90s, they discovered that introducing an audio lure, basically just a loudspeaker that imitates an owl, was really increasing their catch, right? So it became a very effective strategy to study these birds. And so word spread, a lot of biologists caught the cute virus and wanted to work on these adorable little owls. But also it's always really interesting to be working on the frontier of science, right? Like here's a species we know virtually nothing about. Let's come together to learn about it. And then in 1995, our first eruption happened that was documented, and some stations that were very strategically located caught 1,000 owls in just one season. So then people got really interested in continuing this work. So this is right about when Project Owlnet came about. It was founded in 1994 by Dave Brinker, Scott Weidensaul, if some of you have heard of him, he's a writer, and then Steve Huey out of Maryland and Pennsylvania. And basically they got together and said, hey, we're starting to do this. We know almost nothing about this bird. And if we're going to put bans on birds, we better catch those birds again, right? Because it's not super meaningful if you don't recapture the bird again, then you don't get good data like how long did the bird live, where did it go, and so forth. And so their mission was primarily to increase banding for Northern Saw-whet owls and increase recoveries, but also to standardize methods and protocols so that we could build a long-term data set that could be used in the future. And also increase communication and collaboration, because again, no one really knew anything about them. So we all wanted to learn from each other as researchers, and we still communicate constantly during migration season. There's an email thread where we're always giving each other tips and stuff. If you're curious, here's the website, www.projectowlnet.org. And there's tons of additional information about the collaboration. This is a very outdated map. I apologize. I wanted to update it before this talk, and I just ran out of time. So there's a bunch of stations that are going to be missing on here. I know some of you might be familiar with them, but the general pattern holds true, which is that we have a lot of stations out east and not a lot out west. To be part of this collaboration, The project requires long-term commitment, so operations for 10 years, a constant effort, so maximizing trapping days, trying to be out there during the full migration season, standard netting protocol, standard audio lure use, and then of course recording effort data, which is really important because as our effort is increasing, as more and more people are doing this, we need to know whether, if the increase in the number of birds captured and banded are reflective of an increase in the population or just an increase in effort. So we need to collect effort data as well. This is pretty cool. So thanks to this project, Northern Saw-Whet Owls are by far the most banded owl in North America. I mean, they blow barn owls out of the water at 3,615, basically 360,000, sorry. I guess it's getting late. Should I go to bed? I don't know. The number of recoveries is also pretty substantial, right? 10,000 birds. There's a lot of information to be teased from that. So now let's talk about my work above Fort Collins. As you can see, we have a beautiful view. We are working on Crossline Canyon, which is a Fort Collins natural area. It is not open to the public, not now, but it's a very large area and a beautiful refugia for wildlife. It's just north of Laurie State Park. And as I said, it's excellent habitat for wildlife, which means that we do share our banding station with the winner of Fort Collins Bear Week. That's not the one I voted on. Sorry about the noise. Also, this very elegant, large mountain lion, very thoughtfully looking over Fort Collins. So, very humbling to be out there. We do take precautions, but we've never had one of these big predator encounters when we're out there, which is good with me. This is our not so bear-proof shelter, which is an ice fishing shack. It does insulate us from the wind and rain. You can see some of our wonderful volunteers in there with me. You can see me looking absolutely ecstatic to also have a propane heater, because sometimes we'll work in temperatures that are in the 20-degree range. And so we really need that propane heater. And in October, it really is my home away from home. To catch Northern Saw-Whet Owls, we use mist nets. I'm sure most of you have seen these before. They're essentially glorified fish nets with these deep pockets, and the hope is that Northern Saw-Whet Owls will not see them, will fly into them, and then they're gently caught by those pockets. They fall into the pockets and they wait patiently until we extract them, which is what I'm doing here. This is a permitted activity by the federal government, by the state, by the city, so don't try this at home. I know it's tempting, but it's not legal. So now what I'm going to do is just walk you through what we do when we've caught a Northern Saw-Whet Owl to give you an idea of what it's like. Is my mic going on and off? Is that just me? Okay. Okay, good. All right, good. So first things first, we need to weigh that owl. And we found that the least disruptive way to do that is to use this tiny 3-inch diameter can that they don't make anymore. It's an old Donald Duck orange juice can that some of you might remember. Anyway, they are hard to come by, so they're very coveted by banders. But we tear the can, we drop the owl in. It's perfectly sized for a Northern Saw-Whet owl. It just hangs out there for 2 seconds and then we're done. And we find, which, it's well documented, that males and females vary quite a bit. So there's sexual dimorphism between the sexes, and females will be typically 80 to 110 grams, males 65 to 75. There's definitely overlap between the two sexes, but that's just a generalization right there. And of course, mass changes if they've just had a big fat mouse right before trapping them. or if it's the breeding season or winter migration, they'll be a little skinnier as well. Up next, here's my good friend Libby putting a band on a bird. So we put a federal band on them. It's a metal band with a unique number on them. Each bird gets a different number. And on top of the band is written www.reportband.gov. And the hope is, well, we know that other Northern Saw-Whet Owls banders are going to be reporting all of these numbers if they recapture a bird that's already been banded, but the hope is if they also get injured or killed and somebody finds them, then we'll get that information as well. Up next, we take some body measurements to see how big the bird is. We take a wing chord measurement, essentially just taking a measurement of the longest primary. And again, we see big differences between males and females. And that is actually what we use to sex the owl. That's actually a biological term. To assign a sex as either male or female, we use mass and chord. And then we use this chart that was actually developed by Dave Brinker, who I've mentioned a few times. This is a less disruptive way to sex the owl, so we could definitely pull blood or feather samples. But we basically found that there's a pretty strong correlation between sex, wing chord, and mass. And so we just use this table, and some birds that are kind of overlapping, my pointer doesn't work, but that are overlapping kind of in the medium just get assigned an unknown, and that's fine. Up next, we measure tail length. So we just gently stick a ruler on the tail of the bird until we feel the rump, basically the bottom of the bird, and then we just get the measurement of the longest tail feather. That's a measurement that the bird banding lab wants. We look at bill color. So sometimes we see some individual variations where the bill will be two-toned, and so we write that down. We also look at eye color. We use a Benjamin Moore palette. And in case you were dying to know, most birds are 322 or 336. So there's your fun fact of the night. And so both of these measurements might reflect some individual variation, maybe some differences in age or sex, but that's still to be determined, so stay tuned. And last, we look at my favorite, which is molt. So molt is just a fancy way of saying that we look at the age of the flight feathers on a bird. And songbirds, which are much smaller, tend to replace all of those flight feathers, not all at once, but within a year. But raptors, which are larger, take longer than a year because it takes a lot of protein, a lot of energy to replace those flight feathers. The reason why they replace them is because essentially if there's a lot of wear and tear, they won't be as good a flyer, so it's important. So we know that there's a certain pattern that birds use to replace feathers, so we can age them up to 3 years for Northern Saw-Whet Owls. Different raptors are different. Generally, the larger the raptor, the longer it's going to take to replace the whole flight feathers. But it's really tricky to see on the top picture, but there is a slight difference in hue of the brown. Can everybody kind of see that? Okay, that's sun fading. Basically, the older feathers are going to be kind of faded out. And so you could age the bird that way. But owls have this really cool pigment called porphyrin. And porphyrin is a pigment that's found in a lot of other nocturnal animals, not just birds, mammals as well. We think that it's mostly animals that can see in the ultraviolet light. And porphyrin fluoresces under black light. So essentially, we just take a black light to the bird's wing and look at how it glows, hot pink or not. And that's how we assess how old the feathers are. We think this is potentially used in courtship. Of course, females are going to want to choose a more experienced male. So if the hot pink is kind of showing that the bird is young, maybe they're going to be a little more picky about mating with this bird as possible. But porphyrin, just like the brown in the feathers, degrades with time and sunlight. So those older feathers are going to be more white than hot pink under the black light. Make sense? All right, so now let's do a little quiz. Up here, there is a bird that is a hatch year, so first year bird, born in spring. There is a bird that is a second year So let's first guess which one the hatchier bird is. So first year bird. So we're not going to do left and right because that's going to be confusing for me facing you, but just either this hand, raise this hand for hatchier, or this hand based on where the bird is, which side it is on. So let's take a gander. Everybody raise their hands. Okay. I like what I'm seeing. Well done, everybody. Okay. And there's the hatchier, right? Uniformly pink because all of the feathers are new. He hatched not super long ago. And then this is your second year. And so those wing feathers, those primaries and secondaries in the middle of the wing are going to be the older feathers. And then it's already replaced the outer and innermost feathers. Make sense? Any guesses on this bird? How old it is? Ancient. I'm hearing an ancient. 3, 4. Okay. Well, all of you are kind of right because we would call it an after second year. So sometimes we see a wing that's clearly a third year bird, but it's a lot more common for us to just look at the wing. It's irregular. There's no discernible pattern. As you can see on this bird, actually it doesn't show up on the screen at all. But there are some younger feathers on the inside of the wing too. And so it is just an after second year. We know that it's not 2 years old, it's older than that. And that's all we can say about this bird. And that was our last measurement. So now we just release it, let the bird adjust to the darkness a little bit, place it on the hand, and there it goes. When you're really lucky, it poops on you before leaving. Of course, we report the data. So all of the body measurements, weight, the band number, the location and time and date when we trapped it, that all gets reported to the bird banding labs, so the federal government. They have a big data repository. But right now, every station maintains its own effort data. So how many nights we're out there, how many owls we're catching, all that good stuff that's stored by the individual banding stations. All right, that was a lot of information. I'm going to wrap it up soon, I promise. But I did want to briefly mention, the reason why we do all this work, right? It's not just fun. We're collecting data for conservation purposes. So why study birds? So as you know, North America is experiencing some very rapid land use change, resulting from development, human activities, climate change, all that good stuff. And our birds are declining rapidly as a result. This was a very influential study. Many of you will be familiar with it. It was published in 2019, and it showed that in the last 50 years, we have lost 30% of our bird in terms of abundances. And this is across rare birds, common birds, birds of different habitat. So it's not just those highly specialized birds that are declining, it's our most common ones as well. And this has pretty important implications for how the whole system works, right? It's not just important if you care about birds, because birds play very important ecological functions in terms of insect control, pollination, nutrient cycling, all that good stuff. So we need to act now, and we also need to have really good data to track that decline, right? And to understand their habitat needs, their threats. We need long-term data. Northern Saw-whet owls are certainly abundant, at least they seem to be, but that doesn't mean that they're not vulnerable. And so Audubon just came out with this climate report modeling that Northern Saw-whet owls are probably only going to retain 1% of their wintering range by 2080. Ideally, this would also show breeding range as well and how that's projected to change, but we just don't have enough information to model that, unfortunately. It just goes to show you how little data we have for the species. That last model that you saw was just climate related, right? Temperatures, but that doesn't take into account habitat changes as well. And so as you can see here, some of the forest types that I've highlighted in red in the top right are projected to steeply decline in the future as well. We're also experiencing some big increases in wildfires and how severe they are, large-scale fires that actually cause mortalities of nestling of their prey, pretty substantial changes to the forest structure and so forth. And then some forest changes due to tree diseases and insect outbreaks and so forth. That has all become a major factor in our forest health as well. Lastly, there's some urban threats as well we need to be cautious about. So, for example, road hazards, and a study found that out of all of the birds of prey, the raptors that they collected on the side of the road that had been hit by cars, those Northern Saw-whet owls were disproportionately represented, and not in a good way, as you can see. So they are really susceptible to getting hit by cars. Rodenticide is a huge issue, especially for raptors and owls. Rodent poisons are becoming really effective at slowly killing rodents, which means that after poisoning them, after eating poison, they're going to be scurrying about and living for a while, and with lots of opportunities to be eaten by something else. And we do see a lot of die-offs from owls consuming these poisoned rodents that escape people's homes. I can tell you some personal stories about that. One of my barred owls that I was tracking died on my project in Clemson from rodenticide, and one of the Northern Saw-whet owls that we banded, unfortunately, last year was also caught in a rodent glue trap. Yeah, not pretty. Lastly, I want to talk about disease, West Nile virus, avian flu. Those are all going to be impacting populations as well. In 2002, we saw a really big outbreak in Eastern Canada of the West Nile virus, and some rehab centers that had owls in captivity in outdoor cages just all started dying off during the outbreak. Interestingly, we also saw a correlation in banding numbers. So as you can see in both of these charts, that eruption, there's a steep decline right after the 2002 outbreak, and apparently the eruptions were not as big as expected after this outbreak, and they're just starting to recover. So disease can also play a big factor in populations of Northern Saw-whet owls. So I know that was a pretty dire picture, so I want to leave you with some things that you can do at home to help. First of all, if you have some dying trees at home, I know it's dangerous to leave right by your house, but if you have some dying trees or snags, leave them. They're going to be excavated. Cavities are going to be really great for a variety of different wildlife, including Northern Saw-whet owls. So they're great to keep around if you have that ability. Nest boxes are great, especially if you're going to be removing cavities from an area, but there's just some things to be aware of for nest boxes, like predator guards and cleaning and all of that, so that you're not kind of creating this ecological trap for birds. If you can avoid poison and glue traps, I know it's tricky for rodents when you have an outbreak, but they really end up killing a lot of other things. So snap traps are a much better alternative. And then if you can keep urban landscapes forested, so keeping trees in our cities is super important too. All right, this is getting to my last slide, so hopefully you're not all asleep. I want to talk about the future because obviously I'm very passionate about this species, very excited about this project, and I want to do more. There's so much more that we could learn and clarify for this species. So I'm very fortunate to be working for Bird Conservancy of the Rockies. As you heard from John earlier, I really was doing this on my own time, so in addition to work, which is very hard to stay up until 2 in the morning and then go to work the next day. But Bird Conservancy has been very supportive of my work with Northern Saw-whet owls, and we are looking for funding to basically incorporate that as part of my work and support a long-term banding station at Crossline Canyon. Of course, this is going to be filling a very important knowledge gap in terms of how few Western banding stations there are for the species. And it's a great way to use as outreach and band training opportunity for young wildlife biologists. We also are sitting on a gold mine of data, right? Project Owlnet has now banded 360,000 birds, and some for 28 years, and no one has analyzed the data yet to provide range-wide population estimates, which is crazy. But the reason for that is because it's mostly a volunteer-based project, so all of us kind of do it on the side, which means that no one has time or money to be analyzing the data, and we really need that. We have no idea how the species is doing if we don't have range-wide population estimates, so we're hoping to fund that as well. Thirdly, we want to deploy transmitters on birds because there's a lot to learn about getting relocations. There's new technology coming out every day that will help us achieve that goal. And Lotus towers, if you're familiar with those, are few and far between in the West, but they're going to be used in the near future out east to track Northern Saw-Whet Owls. We'd like to join our Eastern researchers and do a parallel study right here in the West. And lastly, nest box study, because Northern Saw-Whet Owls breed right here in the Rockies. There's still so much we don't know about their reproduction. So if you are interested in supporting this work, anything would help, please contact me at marion.clement@conservancy.org and we can chat. But anything would help. And lastly, I just want to thank you for coming here today. I want to thank Fort Collins Audubon, Fort Collins Natural Areas, AJ for giving me the idea of giving this talk, Melissa for helping me find the site for our banding station, all the leadership staff at Bird Conservancy of the Rockies being so supportive of my work, Dave Brinker, my mentor, and all of the volunteers who have come out to lend a hand for the project. Please email me with any questions, and thank you so much.
Thanks.
I don't think I can. Sorry.
Thanks, Marion. I'm sure I'm not the only one who thought that was fantastic. So here's what I want to do. This is partly for your benefit. We have plenty of time to take questions for Marion. And if you're in the room, what we'll do is we'll ask you to raise your hand. And when called on, I don't think we'll bring the mic over. So just try to speak up, and then I'll ask you to repeat the question so that people on Zoom can hear it. If you're on Zoom and you want to ask Marion a question, you can type it into the chat window. So this is your other instruction, is every 3 or 4 people in the room that ask a question, maybe like look at Andrew and see if he's got one from Zoom. I'll just let you wrap this up with Q&A.
Got it. Please.
So I know that they always are moving, but are they territorial like when they're breeding? Like, do they ever fight against each other for mates and stuff like that?
Yeah, so the question was, when breeding, are they territorial? And I think the quick and dirty answer to that is we don't know. But it would be super interesting to look at like 2 breeding pairs next to one another with transmitters to see how they interact. I know that they're territorial with other species, and I would assume that during the breeding season, a lot of raptors do become territorial, even if they're vagabonds during the rest of the year. It can be a pretty small area that they defend, but they need to defend it for resources and keep other owls from hunting that area so that it gets as many prey as possible. Yeah, good question. Yes.
How many did you fan this year?
Yeah, so this year we got 25, but we were only open for 11 days. So that's pretty good. Ideally, we'd be open for most nights in October, but I had a conference and then a trip to visit family, and it's like everything just came together this year, and I was open so few nights. So next year I will do better and hopefully get in the 50s. That's what I'm hoping.
In the same spot?
Yeah. Yeah, in the same spot. Yes.
Have you personally gotten any recaptures?
So I have gotten my own recaptures in the same season, and that recovery I told you about, where one was killed. I know it's sad, but it's still really interesting because we really, very rarely, because they're so small, do we ever get recoveries from the public. Like usually it's always banding stations. And so that felt pretty rare and pretty exciting for me. We still haven't gotten any already banded birds, which is surprising to me, but we're working with such a low number. Like last year I started really late in the season. So we pretty much were on the tail end. And this year I was open for so few nights. So I'm hoping that we'll get recoveries, but also being realistic that we're kind of isolated where we are. There's some working banding stations in Estes and in the Black Hills, but there just aren't a lot of other people banding them right where we are. So yeah, hope to get some soon though. It's a numbers game, really. Yeah. Yes.
I have two questions, please. Number one, simple question. Are there different color morphs?
Yeah, so the only color morph that I know of is that subspecies, the Brooksy subspecies on the island, and that is just widely different from the general species. There's rumor of some of the owls in the Southern Appalachians being slightly different, but I think that's still being explored. And you know, there's just individual variation, but I think mostly there's not color variations like some of our Western raptors that we see here, where there's dark morphs and light morphs and things like that. They're pretty much standard as they come.
Okay.
Yeah.
The second question was, how did you pick your netting site?
Yeah, that's a really good question. I look for habitat. And so typically you want to be on top of a mountain range. I'm not on top here, I'm just on the foothills, but I'm at an edge. And then within the site itself, you may have seen that it's kind of ponderosa savanna, which is not great for saw-whet owls, but right where we are, where we're netting is in a drainage that has a lot of cottonwoods and understory brushy stuff. And so I was like, oh, if I was a saw-whet owl, I would like this area because I would feel safer, basically. That's really what it comes down to. So it's kind of in this wetter area of the landscape, and that's why I picked it. Yeah, thank you.
Yeah, several on Zoom here. First, can you show the slide with the owl longevity chart?
Sure. Is there a follow-up question about?
Nope.
Okay. There it is, right?
Yeah.
There it is.
All right. Next one is from Caitlin. Do saw-whet owls wander when they migrate, or do they have a strict north-south migration path?
Yeah, that's such a good question. I wish I could answer it better, but we just don't have enough information. So right now, our understanding of migration is strictly band recoveries, which is really tricky, right? Because you're just happy to get the same individual in one season, point A and B. That gives you a lot of information, but the odds of you catching it again are really slim. And I don't have any examples off the top of my head of a bird being caught 3 times in one season. So once we do get modus transmitters or other types of transmitters that actually follow their migration, we'll be able to answer those questions. But right now we don't know if they just follow air currents and the wind, or if they have a strict trajectory. But in general, it is north to south, just because they are escaping like snowstorms and stuff like that. They are cold hardy, but if you think about it, they're not like a great gray owl that's going to be able to pierce through the snow, right? It's a relatively small owl. So even though it is cold tolerant, that doesn't mean that it can hunt in heavy snow conditions. Yes.
When you're banding and measuring these owls, how cooperative are they?
I love that question so much. You know, they are very cooperative, for me anyway, who has banded a lot of other owls that I have to worry about much more. Like I tell people who train under me that Northern Saw-whet owls are actually the worst raptor to learn to band, because you can make so many mistakes without any penalties. And their talons are really small and they can make you bleed, but it's usually when they foot me, it's like I don't even say ow, you know, I'm like, oh, good job. So in terms of temperament, yes, there's definitely individual variation, and there's some that are so easy tempered that they like barely try to bite or foot you when you're handling them. They just stay still and let you do whatever you need to do. And then there's others that are definitely a lot more, you know, like flighty. They'll flap their wings more and try to bite and stuff like that. But in general, they're really docile. Yeah. Yes.
So if one found a bird with a band,
Mm-hmm.
how do you report that?
Yeah, so if you just Google search report band, you will find the federal website because it's used a lot. It gets high traffic, but I'm pretty sure the website is www.reportband.gov, but there might be like a dash in there that I'm not remembering, but it's written on the band. So it's not just a number, it's written on the band. The only time you'll find a bird that's banded and where that might get a little trickier is if it's a color band. So like a plastic band that's red or blue with some big letters. That's a banded bird from a local study that's trying to do like a bird count from respotting the bird. You're not going to see that on Northern Saw-whets because they just, first of all, they're not territorials. They don't come back. So it would be useless to put color bands on a bird. But also they just have such thick feathers on their legs that that band would just get buried. Yeah, and I did forget to mention that, but on larger birds like eagles and pelicans, sometimes you can take a high resolution photo of that metal band and then end up, you know, stitching the numbers together and being able to report it that way. But that's not the case for an owl that's so small. So the odds are you'll be close enough to the bird at that point that you'll be able to read the band and it'll tell you right on it and how to report it. Yeah.
You were talking about whether there was a hyphen and your web address. I just want to mention, I think there's a period in your email if anyone wants to contact you.
Oh my gosh. Thank you for mentioning that. Let's go back to it.
Because I hope everybody does email you after this.
I know, that would be so bad. Well, you can also Google my name and Bird Conservancy and you'll find me on the staff page. But yeah, there's no period. I'm so sorry. Thank you for mentioning that. So in between my first name and my last name, there is a period. I can add it. All right, I can multitask. Next question. There it is. Thank you, Allison. Whew.
Several more on mine here. Courtney asked, if known, what is the average territory size radius?
Yes, that is a very good question. You know what's funny is I wrote it down and then I forgot. Let me see if I can bring it back out in my notes. But you know, all of that is going to be very, very, very rough. Just because we don't have a ton of data. 1 second. Here it is. Oh no, you can see all my notes. Okay, including my puns, huh? Now you know that it was not impromptu. So 370 acres is what I'm seeing. I don't think that's very accurate. So I would not rely on that estimate because that is very, very large for a very little bird. So, you know, home range is defined in many ways. And if that was done with a minimum convex polygon, it ends up being, you know, very large compared to what it actually is. So I think the right answer for that is we don't know, but we will when we put transmitters on birds. And that's part of the interesting thing is, you know, we hope to put transmitters on migrant birds so we know what habitats they prefer and where they go, but also on breeding birds to see where they forage and how big their territory is. That hasn't been done before. Not to my knowledge. Yes?
I have a couple of questions about the roles of male and female when breeding. You said the female is does the incubating, when she gets up for the poop break, does the male come in and incubate at all?
No.
Okay.
In some species they do, but not in this one, the female only. So when temperatures are a little milder, warmer, those eggs are gonna keep themselves warm, especially when they're packed together. The ambient nest temperature has a little bit of a wiggle room before the eggs drop too low. Also, a really interesting thing about eggs is that although they need to be maintained at a specific temperature, they actually have a wide range of temperatures that they're, there it is. Okay, I knew it was cutting out. They have a wide range of tolerance for temperature. So as long as it doesn't drop below a certain level where the egg becomes bad, essentially, and kills the fetus, dropping temperatures will just slow down how quickly that egg is going to develop, but it's not actually going to kill it. And so she's got a little bit of wiggle room. Wiggle room.
So then the second question is, you said that the male feeds the young for 2 months afterwards. Is it only the male that does the hunting, or does she also feed the young at that point?
Yeah, so again, this is based on just a few observations, but it has been documented that the female sticks around and helps feed the chicks. And it also has been documented that when the chicks get big enough, she leaves. Like she doesn't even stick around to raise the brood. She just says, I did my job. I stayed in that nest for 2 months. Now it's your turn. So it's hard to know like how often that happens one way versus another. But yeah, the male does all the feeding. It's very separated.
A few more. Time for a few more.
All right, just a few more.
Go ahead here to Zoom.
Yeah, we got a couple more on Zoom here. Is the molting where it's one feather at a time, or clump molting like screeches?
Yeah, that's a good question. I think it's mostly, I guess the answer to that is I'm not sure. But I think it's probably a little bit of both. Like if they have enough energy and protein, then they're gonna do like 5 at the same time, essentially. Although for raptors, you have to keep in mind that unlike waterfowl, for example, that can just shed all of their flight feathers and not be able to fly and still feed themselves, raptors in general always have to be able to fly. And so typically, even if multiple feathers are molting at once, there's going to be like a sequence to that where one is much more grown in than the other, because if they have too many flight feathers that are missing from their wing, they're not going to be able to hunt effectively, and then they'll die. So it's a bad evolutionary strategy. So, yeah, I think it's more than likely sequential, maybe 2 at a time or 3 at a time at the same rate, but that's about it. What? Sorry.
Yeah, there's a couple more.
Do
you have a sense of whether the Northern Saw-whet owls in this area that are breeding migrate?
No, I don't have a sense for that, but I think when we talk about Northern Saw-whet owls being year-round residents in the Rockies, that doesn't necessarily mean that individuals are staying put. It just means that we see them year-round. So it could be that Canadian birds are coming to the Rockies to overwinter, and then our birds in the Rockies are going further south. So again, they're like, I call them little agents of chaos. They just kind of do strange things. And so my guess is that they move around quite a bit. Yep.
Last one here. This is a slightly silly question, but owls seem to have strangely long legs.
Do these? Okay, first of all, I think that question is based off of this internet meme where a great horned owl was like raised and its legs extended way out. And I don't know, I can't say for sure, but it seems like that owl was maybe edited with some Photoshop capabilities. Yeah, I've never seen one with that long legs. I mean, they do in general. Birds, the way they kind of tuck their legs in is that it's like the knee is kind of held up close to the body, and then their leg actually consists of, what is this, tibia? You know, tibia, and then the foot. And so, yeah, their legs will always be longer when you stretch them out than like how you would see a bird stand, basically. But I don't think they're as long as that internet photo. So, yeah, fair question. One more. Okay, from the audience. Yes.
I've got a general question and a quick follow-up, and that is land use patterns for these birds. What interaction do you see with land use and how that's changing, and how that affects owls and the other birds that you've studied?
Yeah. So, are you talking about like fragmentation?
Fragmentation, development, farming.
Yeah, so we don't have a good sense of how it's affecting saw-whet owls specifically. I suspect that we'll get some of those answers from transmitter data, because right now our understanding of their habitat use is based on just observational data. That being said, you know, in general, land use impacts different birds differently. So some grassland bird, for example, benefit from certain types of agriculture, from grazing and so forth. Certainly open habitat raptors and birds and owls like barn owls will benefit from certain types of developments as well. So it depends on the species that you're talking about. Forest birds in general are going to benefit from a forest that has structural complexity, so a variety of different ages of trees of different heights and so forth. But it depends on the species and their needs, right? So it's a tricky question to answer, and it's one that scientists like to study a lot because we need to focus on the positives too, right? Not just the negatives. So certainly some groups of birds and animals are going to be very negatively impacted, but others are positively affected. And so it's interesting to study those differences, why some birds are doing better than others, and what we can do to encourage a more diverse taxa of wildlife in our developed areas.
And the follow-up is specifically about renewable energy. There's a lot of concern about the large area that, say, wind farms and solar farms take up, and how that might be affecting it.
Yeah, that's another tricky one. So wind farms are typically placed in open habitats. I'm assuming solar is the same because we don't want to cut down a bunch of trees. Yeah, it's a complex issue. I mean, there's weird phenomenons where migratory birds are sometimes attracted to solar panels, for example, thinking they're water. Certainly wind farms certainly have a role to play in learning how to minimize some of the casualties from eagles and even bats. But it's also renewable energy, right? So in some sense, yeah, there's trade-offs to everything. I think, you know, as humans, we're pretty smart. We're always coming up with new ways to generate energy. I mean, now we're making, you know, glass windows that generate solar energy, even though they're clear as can be, that can be placed on buildings, and that emit rays that are visible to birds so they don't hit windows, you know? So we're constantly coming up with new strategies. And I think it's important to highlight some of these issues with their renewable. I mean, certainly they're not, you know, angelic and perfect, and there's a lot of room to work on how to make sure that they're having as many benefits and as few consequences as possible.
Sadly, we are out of time for questions. Join me in thanking Marion for fantastic